aware of what we're doing also. And there we go. Okay, so what we're going to do today is we're going to finish up that discussion on sets and maps. We're going to finish up that discussion on sets and maps, and we're going to look at a couple of examples. Specifically, we're going to do maps today. So we did sets, and we did, like all the different hash sets, tree sets, stuff like that. And if you remember, sets were the only rule was that it was a collection, and the rule was that you couldn't have duplicates. So something is either in the set or not. So what we're going to do here is with the maps is imagine that if you had a set, but for each item in the set, you wanted to have a value associated with it as well. So maybe it might be a value like an integer, like how many times it appears in the set. So remember, you can't have duplicates. You might say that you can't have more than one of the same student, for example. So like just looking at my screen here, what should not your faces because your cameras aren't on, but just who I can see logged on right here. You got Yusuf, NS, Ismail, and Okan here just up on the main screen for me. Right, so each of you is in the set, and 15 of you are here today. So you are in the set, you're here. But what if I wanted to say, okay, how many times did someone, so just looking through the list, Bushra, for example, or Murat, or Sevinch, right? How many times have they joined a class? Then we could say, okay, well, we put them in the set of people who have joined a class, but we want to have a value associated with that as well. Okay, so that's kind of what a map can be. Okay, that's kind of how we can use. That's not the only use for a map, but it is one possible use for a map. So let's go ahead and I'll switch over to the slides now. Okay, and let's see. Okay, let me scroll back up. Okay, so yesterday we ended on this whole performance of sets and lists, and we talked about the case study of counting keywords. Okay, so today one of the fun examples here that we're going to look at is not just counting keywords in general, but if we were given a piece of text, counting how many times a word appears. Okay, all right. So let's just discuss first, let's introduce the whole map concept, okay? So you have a search key, right? And then a corresponding value. So you have a search key, like maybe like an ID, a Kimlik number, or a student ID number, or something like that, or a phone number, So, kind of like we have in the store program that you guys are creating, that you guys are still working on, because there is that assignment due today. I believe it's due today, right? You'll have another assignment for that. It should come out either today or tomorrow is when I should be done finishing writing it up. Okay, but you have maybe a phone number and a customer, right? So anyway, this is the whole idea, is you have a search key. So if we look at the search key as being like a set of values, we can't have duplicates here because this key corresponds to a certain value, right? So this ID number belongs to John. This ID number belongs to Peter. This ID number can't show up more than once, so it's like a set. This ID number can't show up more than once because if it did, then it could belong to somebody else. Just like if someone else had your Kimlik number, that could cause a lot of problems in a system, right? In everything from banking to your student, your university, your school stuff. There's all kinds of problems that could come up if two people were allowed to have the same Kimlik number. All right. Now, don't be confused though, because you can have duplicates over here. Okay, you can't have duplicates in the search key because the key points to a value. Key points to a value. That doesn't mean that the same thing can't be the value. Okay, so we can have, for example, if the corresponding element value was a number, the same number could appear twice, right? So as the example that I gave at the beginning of this lecture was, if our search key was, say, your student number or who you are, your name, or just some kind of search key to determine who you are, and this value was the number of times that person joined one of these online lectures, or the number of times that that person showed up to class if we were taking attendance, that kind of thing, then you could have the same number appear more than once, right? Because you could have some students that have attended the same number of lectures. In fact, you would expect that that would be the case, right? You would expect that there would be, unfortunately, there would be a lot of zeros over here, right? For students who had never come at all, and there would be a lot of like numbers like 1, 2, stuff like that, right? And then there would also be some numbers at the higher end as well for students who have been able to come consistently. And especially now with the fact that so many students have don't have access to high quality internet where their hometowns are, means that they're not able to join. So anyway, so that's the idea. You have a search key. The set of search keys acts like a set. Then there's a value for each key in that set. Okay, I won't spend too much time on this. This is the kind of the understanding of how the hierarchy and classes and stuff work for this. So just kind of, I want this to be there for you to have, for you to understand it. Again, these slides are available on the Google Classroom, so please review them at your convenience. Okay, but so this is kind of how it works. This is just kind of make sure you understand kind of how things inherit from stuff. Okay. All right. So we can have some special, I do want to go ahead and have some short discussion on some of the methods that exist on the map interface. We can say, does it contain the key of a certain object? Now notice that in a map, both the key and the value, so KV pair, the key and the value both are objects. Okay, so if we wanted to put a number as the value, an integer, we would have to use the integer object. We would not be able to use the primitive int type. Okay, but we can check if it contains key. This is basically the same thing as in the set interface where we had the contains. Let me go back and show that. Right here. Nope, this collection. Well, it contains, it's a collection, right? The set, that's tree set. I guess doesn't have it there, but it has the contains object, right? So that this is similar to that. The contains key works the same way as the contains method for the set, right? It's just telling it, is it there? Contains value tells me whether or not this value appears somewhere in that. Now, this again, contains key, no duplicates allowed. Contains value, it's just telling you whether or not that value shows up somewhere in the map. Okay. All right. So the way that we add a key value pair, we put this here. We're going to talk about this a little bit in this lecture. Is the idea is what happens if the key already exists and we try to put it? What should it do? If we try to put a key and a value that where the key doesn't exist already, what should it do? And so we're going to talk about what that does and how that works. Okay. Let me see one other thing. Okay, the get. The get. You send it an object as a key. If that object is one of the keys of the map, it will send back the value that that key points to. So here, if we look back at our example, if we were to use get with this 111343434, we would get back John. Okay.
Mommy's making salad.
Hold on just a second. Sorry for that disruption. Okay, where are we? So get, yeah, if we pass it the object, we get back the value. Okay. One thing I do want to point out is another way to look at this map would be, so we've talked about arrays, we talked about array lists before. Another way to look at the map interface is, what if we saw it as an array where the index, instead of being an integer index of the position in the array, what if it was indexed by an object instead? Okay, so it could be indexed by a string. It could be indexed by, some other thing like a student. It could be indexed by a product if we're talking about the store, right? So if we wanted to have each store be able to maintain how many of a product it has, then we could index their map with the key would be the product, and then the value could be the number of products that are there, right? The number of products that it has in stock. Okay. So then get becomes just like the array list get, but it also becomes kind of like when we would index, pass an index value, an integer value to an array and get back that thing at that position in the array. Put would be like putting something into the array. So it'd be the same thing. At a certain index, put this value, right? So that's kind of how that would work. Okay, so if you want to think of it as an array where the index value, instead of being an int value, is an object instead, that would be a fine way to look at it. That would be correct. Okay. So some of the concrete map classes, we have a hash map. That's the one we're going to look at today. We also have a tree map, just like with the set, we have the hash set and the tree set. Hash map is unordered, just like the hash set was unordered. Tree map, just like the tree set, is an ordered version of that map. Okay. Map entry has the whole key value pair also. Okay, so like I said, the hash map is unordered, tree map is ordered. I won't go into too much detail into the linked hash map. I really just want you to know about the hash map specifically, and a little bit about the tree map too would be good. Okay, so if we look at how to test this map, we're going to look at this example in just a few minutes. Okay, and we're going to see just how it works. I really think seeing examples and just working through them is really the best way to kind of learn this stuff. So we'll go ahead and just kind of do that. But I did talk about this, and I kind of gave this as a heads up that we would also look at this count occurrence of words. So instead of just counting if a certain set of words appear somewhere in a file or a piece of text, then what we're going to say is, okay, let's count how many times some words appear. Okay. All right. So let's look through this example real quick. Program counts the occurrences of words in a text and displays the words and their occurrences in ascending order of the words. So there is an ordering going on. Program uses a hash map to store a pair of consisting of a word and its count. For each word, we have to first check whether there's already a key in the map. If it's not, then we need to add the key and a value 1. Okay. Otherwise, increase the value for the word by 1 in the map. So, okay. And then to sort, we'll convert it to a tree map. So these are steps in what we're going to develop. So we're going to have to store a pair of a word and its count. Now, the reason why we add the key and value 1 and not 0 is because if we had zeros in there, it would mean that we would have to store every possible word in whatever language the text is in, right? Whatever, it's going to be just a string of text. It's a couple of sentences. It's in English. So if we were to say, okay, we need to add this, and it needs to, be zeros for any words that don't appear in the text, we would have to have a map that consisted of keys of all of the words in the English language. Quite a large undertaking, right? So what we do instead is we start with an empty map, and if the word does not appear yet, right, which the first word won't because it's an empty map, we add the key and value 1 because now we have seen the word one time, right? And then anytime after that, if we run across a word a second or a third time, we just increase the value by 1. Okay. All right. I won't talk about this last slide because you guys did that in the lab, to my understanding, was about the singleton stuff. So we'll just, since you guys covered that in lab, we don't need to cover that today. All right. So as long as there's no questions or comments yet. All right. Let's go ahead and talk about this. All right. So let's do the test map first. Okay. So we have a map, all right, that has a string as a key and integers as, oh, I'm in the wrong folder. Let's see, here we are, lecture examples. All right, there we are. Okay, so we have the map with a string and an integer. So the key is going to be a string, an integer is going to be the value. Now, remember, we can put this in as an int here because it will automatically be boxed into this integer object type. Okay, so that's going to happen on its own. All right, so we're going to put the value Smith 30. We can put the value of Anderson, put Lewis, put Cook. Now remember, the keys act like a set, which means we cannot have duplicates. So what's going to happen when we try to put Smith with the value 35? Well, let's take a look. All right. So let's see what the hash map looks like. Okay. Notice this looks very similar to the hash set, doesn't it? So Smith is in there, whereas, let's see if I spent. Notice it has a key and a value, a key value pair, right? Anderson, where's Anderson? Anderson's here. Lewis came over here. Cook came right here. Now let's see what happens when Smith tries to get put in as 35 instead. Notice all it does is it changes that value. So put acts just like that array stuff, right? Remember how if we had an array at index 0, for example, equals 30, right? If then somewhere else down the line we change that to array of 0 equals 35, all that would happen is we would just replace the value there, and that's all we're doing. So all that put does, put acts for a hash map the same way that this index, right, this indexing on an array works. Okay, same thing. Okay, so if we display the map, okay, notice it's a little bit different in how it displays. It doesn't display with that bracket. Instead, it uses these curly braces format. So where it has key, value, key, value, key, value, key, value. Okay. Tree map is going to work just like a tree set. Right, that we created it from the hash map. Notice it's in this, it's an ordered thing. So if we look at the ordering from left to right, A, C, L, S, it's ordered. Notice it's ordered by key. Right? There's no ordering to the values. It's ordering by the key, just like the tree set does. Okay. So if we want to display them, because we're going to display the tree map, which means it's going to go through, just like this one went through the order that it happened to be in the hash, this is going to go, it's going to display in the order that it is here. Okay. Right there. Okay. Just for fun, let's take a look at what the linked hash map looks like. All right, so we're going to put this whole thing again. All right. It looks very similar. It looks the same. Okay. And I think what happens is this becomes a linked list up here instead of just a normal array list. All right. So if we want to get a value, we use the get method. All right. So we get at this index for Lewis. It should give us the value 29. Page for list 29. Yep. Display the entries in the linked hash map. Okay. Now, what the order is, not entirely clear on here. Oh, it was displayed in the order that. No, it wasn't displayed in the order it was put in. Not sure if there is a ordering for this. All right. Again, just like we talked about yesterday with the set, we can do the for each. We have this for each. So for each key value pair, print those things. Okay, so the tree map will do this. It's going to be in order because it's the tree map, so it should come up with Anderson first. All right, Cook, Lewis, and then Smith. So notice what happens with the for each. Just like in that test set with the for each, where we had a variable and then we did something with it, where for each value in the set it got put in there. Here we do a key value pair. So what happens is it creates a variable called name and it puts the key into name, and it creates a variable called age and it puts the whatever the value is into that age for each entry in the map. Okay, so name gets whatever the name is, and the first one is Anderson. So it gets that value. So when we go to print, we use that value, and age gets whatever the value is for Anderson, which in this case is 31. Okay. All right. So that's kind of how you would work with the map. Okay, I'm going to close this out and discard. All right. Let's talk about counting occurrences of words. So here we're going to have this string of text. Okay. And what we're going to do is we're going to create an array of words, an array of strings based on this text. And what we're going to have is we're going to have this map that starts out empty with a set of strings and a set of a set of strings. And for each string, that's going to have an integer value, and that integer is going to represent how many times that word has appeared. Okay, and basically, this is going to like remove all like spaces and punctuations and stuff like that. So, okay, so we're going to take. I think it takes out the punctuations. Okay, so we're going to for in this array of words. So we're going to parse through one by one these words, right? Two lowercase. If okay, so first of all, if the key dot length is greater than 0. So what's the key? The key is the particular word we're looking at. If it's greater than 0, if it has more than 0 characters, so it's not the empty string, then we're going to check, does the map contain the key? Because there's two different, you have to think about this as being two different ways to look at this, right? One is that the map either contains the key and has a value. It's already been seen in the text before. Right? The other is it could not be there already. Okay. So I hope did I say that right? One option is that it has not been seen before. One option is it has been seen before. And so we have to treat that as two different things, right? Two different possibilities. If it is not there already, if it's not been seen in the text before, then we want to go ahead and put it in the map, and we want to say we saw it one time. The other possibility is, okay, if we saw it in the map, if we saw it in the text before, we want to take the value for that word, we want to add one to it, and we want to put back that value. We want to change it to that new value. Okay. All right. So let's take a look and compile. Let's do it this way and debug so we can see how this works. Okay, so we have this text, this good morning, have a good class, have a good visit, have fun. So have appears a few times. Okay. So now so the map is empty. There's nothing in this, right? Okay, so now we split the words. So the words, what words there are, good morning. So this split on the punctuation, as I thought. Okay, it takes the punctuation out. Okay, good morning, have a good class, have a, and then there's actually more to this array. Okay, it's going to be have a good visit, have fun, right? Okay. So now we're going to look at the words in the array. What's words.length? It's however many words there are. All right. So we're going to say, okay, the key is whatever the next value is. Well, int I is 0, so it's going to be good, right? So the key is good. Is it greater than 0? Yes. Does the map contain the key? Well, the map doesn't contain anything, so no, it's not there. So map contains key is false, not false is true. We're going to go into there. We're going to put the key in the map with the 1. So map should now be let's see, good with the value of 1. All right. Probably should have used this so you could see it visually, kind of how this works. But okay. So now we're going to keep going. Next word, morning. Does morning appear in the map? No. So we're going to put it in there. Okay. Yeah, I should have used the canvas so you guys could see this visually. All right. So now we're going to go back and have. All right. Now. Oh, sorry. First nothing and then have. Does have appear? No. Next one is A. Does A appear? No. Okay. Good. Now we get to some fun one, right? Does good appear? Yes. All right. Map contains key is true. Not true is false. So we'll go to the else here. All right. So now we get the value. What's the value for good? Well, we've seen it once. 1. So we're going to add 1 to it. All right. 2. So now we're going to put 2 for good. So yeah, good. Class doesn't appear, so we will just put it. Have nothing. Have does appear already. So we're going to add 1, make it 2. What about A? Does A appear? Yep. So we're going to make it 2. What about good? Does good appear? Yep. So we're going to make it now 3. What about visit? No, visit doesn't appear, so we're going to put it in there. Nothing. Have, does have appear? Yes. So we're going to make it 3. And fun, does fun appear? Does fun appear in this class? I'll let that. I'll let your muted mics tell me that one. Okay. All right, so now we're going to display each one. Right now, the reason why we used a tree map for this was because we wanted to display them in ascending order of the words. So what's going to appear? it's not going to be good with a capital G because we put the key was the two lowercase, right? So for each map, for each value, for each key value pair, we're going to print the key followed by a tab followed by the value followed by the number of times it appears. So we step on this and we see that A, notice this is alphabetical order. A appears twice, class appears once, fun appears once, good, have, morning, visit. Okay. All right. So that's how you might use a map, right, to be able to count the occurrences of words. You could use a map, and the nice thing about maps is, let me run this out to the end. Okay. The nice thing about maps is that really anything can be your key and anything can be your value type, right? It's making a mapping, which is why it's called a map. It's making a mapping from a key to a value. Okay, so you can even have as the value be another map. So let's say, for example, I wanted to have a store. Okay, let's say I wanted to have maybe I'll make a new one. Okay, let's say I wanted to have a store, and let's say I wanted to have a store be the key. Okay, so a store object is my key, and I wanted for each store to have a map of products and for each product in that store's map, it would have the number of in the inventory. Okay, so the way we could do that is, so you have this store class, right? You have a product class. Okay. Okay. And what I could do is inside of some, what would it be? Like a main program. Okay. So I might have a all right. And by the way, this is not what assignment 4 is going to be. Okay, it's just an example of how you could use a map inside of a map. Okay. So what if we wanted to have a map where my key was the store and the value was not, it could be we could do an array list, right, of product. But what would be better? What would be better would be, what if we had as the value for the store would be another map? Okay. Okay. And what would be the value for that map? So basically, and we can make that, it's an integer. Is the way I would do this. Okay. So what we've done here is, let's talk about the submap first. What we've created is a map of products to integers. And what that means is that in this map, every time when I encounter a product, the integer is going to be a value. It's going to be a number. For us, what that could represent would be how many there are in the inventory. So, for example, if you went to Migros, right, and you said, I want to pick up Snickers bars. I always use Snickers bars. Let me switch to Oreos. I like Oreos better than Snickers. Okay, so I would have inside of that map for Migros, I would have Oreos and 20, for example. So the product object would contain the information about price, about calories, because it's a food product, stuff like that, right? And then the value, so the product would be the key, the Oreos would be the key, integer would be how many it has in that. Okay, so now that's how we would define that map. So this map would be this large inventory of products and how many are in that. Now we can take that map and put it as the value for this map. Okay, and what happens then is I access it using a store key, right? And I say, I want to know what products, what's the inventory for this store, right? So Migros has this list of products and values. If I said, okay, I can put a new store with another map value, okay? So A101 might have something else. So a couple of issues with how you would do this, okay, with a couple of issues with this design. This would work really well if I wanted to very quickly get the list of inventory and values for a particular store. If I said, give me the inventory for Migros, I could have that very quickly. Give me the inventories for A101. I could have that very quickly, right? The problem would be, how would I say, okay, give me the list of stores that have Oreos at them. Okay, now that becomes a little bit harder because then I have to search through for each value, for each store, does its map contain Oreos? And I have to go through and loop that. So it becomes a little bit harder, right? I can't just get a list of stores very quickly. All right. So that becomes a little bit harder to do it that way. All right. But if I wanted to add, if I wanted to add a store, right, I just put Migros, put the store, and an empty map. If I want to add a new product to that store, I just put into that value. Okay. If I want to change what the inventory is for a map, I could do it by using the put also. Okay. I may try to come up with another example where I can show you this as well. But one thing I realized I forgot to go over with this count occurrence of words. Okay, because some of you might be looking at these 3 lines of code right here, and you might be thinking, hey, wait a second. Why do I need to create this value variable? Couldn't I just do this? Okay, let's see what happens when we try to compile this, right? Oh, that's not working. Right. Found a value but requires a variable. Oh, I know why. It needs parentheses, right? No, that's not right. Wait. We don't have to change this. We're putting it right there, right? This work. Hey, wait, does that work? Let's see. Yeah, it sure does. Right. So this would be a way that we could modify this code to run a little bit more efficiently, all right, without having to create an extra variable in there. The reason why we created it this way initially was so that you could more understand kind of what's going on, that we're taking the value, we're adding one to it, and then we're putting that value back in there, right? Because you needed to know that you had to get the value, change the value, put the new value in there. Because what we could have done if this were an array, so if this were an array instead of a map, right? If this were an array of values that was indexed, And if I wanted to, if the array contained integers, right, ints, int values, right? If I wanted to change an array at a specific index, I could just do the plus plus on it, and that does it, right? That just changes the value. We can't do that with a map. We can't just say, what we can't do is we can't just say, this we can't do, right? Because this gives me an integer. This is a method that returns a value. I can't use it to also change a value. Okay, what I have to do is I have to get the value, I have to add one to it, then I have to put this new value back in. Okay, so I hope that's clear about why you would do it that way. The main thing that I want you to take away from this, especially for your upcoming assignment, when I'm done writing the description for that, is if something exists in the map versus if something doesn't exist in the map, what do we do? Okay, if a product is already in our inventory and we want to change, right, what the value is, how do we do that? If the product doesn't exist in our inventory, how do we do that? Okay, all right, hope that's clear. I hope that's kind of clears things up a little bit. If there's any questions, pop back over. Okay, I don't see any questions showing up. So again, your assignment, my understanding, let me see. If I remember correctly, yeah, I extended the due date to today. So it's due today at midnight. So if you have any questions, make sure you get them to me. If you have any chance of me being able to answer them, you need to get them to me as soon as possible. Otherwise, it might be too late. All right. Okay, guys, so thank you for joining us, and we will see you again next week on Wednesday. Oh, and remember, you don't have a lab this week because of the holiday tomorrow. So I'll see you on next week.